Okay, in this project, one of the viewers asked me if we can use the Otter Lite for making a 3D scan of the car seat. I recommend him the Otter Lite because it's very good at tracking in a large mode, and it does not require to apply the marker, so it will be quick and easy to scan the car seat. And he told me that the car seat that he's going to scan for is for making a cutting pattern. So making a cutting pattern requires only 5 millimeter for the tolerance. So the other light could be suitable for making the 3D scan of the car seat. As you can see, there's direct sunlight on the seat, so I need to cover up because the 3D scanner cannot scan in a direct sunlight, but in the shade like this is fine. But it may be difficult for you to see. Let me grab the outer light. When I scan in the large mode, you need a space. I mean, you have to back off far enough. Normal, large mode, geometry. Okay, let's click on the scan. You need a distance to back off. This will be a good distance for scanning the car seat. It would be ideal if you can remove the seat for scanning, but if you don't, I think it's fine. See here, I'm not crashing with the steering wheel in the driver's seat. So this would be working distance when you scan, when the car seat is in place. Okay, so I will start the scanning. I start with the headrest because the Otter Lite track very good with in the large mode. See here, it's no drifting. It's tracked the car seat very well, so I highly recommend if you do upholstery business and you need to make a cutting pattern for the car. Okay, so you need to avoid the flat surface, but most of the car seats is not flat, right? So you need to because the capture area is really large, so you can't scan this very easy. See, on the backrest it has a lot of curvature, so it's quite easy to scan, but on the seat it's quite flat. Let's see, stop scan. Okay, I think we have everything. And in the case of you don't have a fast phone, I also don't have one, you can use a laptop, a gaming laptop for scanning. Okay, it's all done. So now I'm going to process this, and I probably measure for the distance and check it in the point cloud so that you know the accuracy. Let's move to the point cloud processing. Okay, next I'm going to process the point cloud. Okay, for objective size, I will go for 0.5 or 0.6 millimeter for the resolution. Okay, here's the scanning result from the Otter Lite in large mode. This is very good. You can even see the texture pattern of the fabric. Export this as the point cloud so I can check the dimension. And then I will mesh this one for reversing the pattern. When reversing the pattern for the car seat, I will use Blender shrink lap function to create a 3D lines, because the Blender shrink lap function is very good and quick. And then I will use the 3D lines from the Blender, import it into the Autodesk Inventor and create a surface, and then I will flat it, because the Autodesk Inventor it has a flat function that you can unwrap the car seat pattern like this into the flat pattern, and you can send it to the CNC cutting machine for cutting for the pattern. Okay, so from this point to this point, a 310 on the seam line. Okay, let's check the accuracy. I think about from this point to this point, 311.6. I measure with the measuring tape 310, so it's quite accurate for this, because the measuring point is not in a sharp corner. Could be plus or minus 2 or 3 millimeters. Anyway, I think it's accurate enough for making the cutting pattern. Okay, let's look at the quality of the scan from the render scene. I'm going to make a cutting pattern for this top part of the backrest. Okay, let's move to the blender. So I'm going to import the mesh into Blender. File, import OBJ. Choose a file, scale it, 0.001. Import it. Click on Home. I'm going to change the unit to centimeters. Click here, click on End. So the size is correct, 60, 89, 73. Next I'm going to align this object, apply or transform. So scale is applied to the object. Next I'm going to move it, GZ, GX, GY, R, GX. Okay, so it's quite in the center now. Okay, let me save it. Okay, with the blender, it's now saved. Okay, next I'm going to create a add. Okay, before I do that, let's check here. Click on random surface color. So the new object we have a random color. Object, add, mesh, plane. I think the size would be 5 by 5 centimeters. So I make a grid, GY. The grid size, the grid has almost the same color, GZ. I'm going to rotate this. Okay, I rotate this 90 degrees, GX, GY. I put it closer here. Next, I'm going to shrink wrap this onto the surface. For that, I'm going to click here, snapping tools, snap on the face, and then I'm going to click on the modifier, add modifier, deform, shrink wrap, and I'm going to select the target, which is the car seat. So now this small rectangle mesh is snap onto the seat of the car. Next I'm going to apply the modifier to make it easy to see. Click on viewport display here, click on in front, so it's in the front of the viewport. Okay, next I enter edit mode. Click on here, lasso tools. So I'm going to create a extrude. So anything you extrude, it will be snap onto the face of the seat. So I try to place the line closer to the seam. So you need to turn. In this way, I like using the mesh for tracing for the fabric surface, because you can't see the seam line, the original seam line, very well. Okay, so I will make only half of this pattern because the other half is symmetry. So I make only this half. Let's try to fill with the face. Okay, I think I'm going to make another low here because it's curved. Okay, subdivide, move it here. So what I'm doing here is to simplify the mesh, make it less complex. From 3 million faces, we go down to just a few hundred. So you can choose your own topology of the mesh. I like to do it manually because you're the one who knows which part has a high detail or low detail. This part is low detail, so I can just make it in a one rectangle like this. So okay, let's extrude a little bit more, going down this way. E, and E. Okay, all done for creating and simplify the mesh for the car seat. This is just one pattern. So next I'm going to export this as a 3D lines. Click on the file, export, AutoCAD, DXF. This is an add-on in the Blender. You can export it. I select on here, export as the line. So it's to export this one as a line in a 3D space. Click on export. So when you open this file that export from Blender in AutoCAD, you get a 3D line which can be used to create surface and unwrap for the flat pattern. But you can't unwrap it here in AutoCAD because it doesn't have this function. So you're going to need to reconstruct the surface by using Autodesk Inventor, and then you can flat it. Okay, this is 3D lines that we export from the Blender, and this is in Autodesk Inventor. Next step, I'm going to create arc lines because we can't use a segment like this. So I'm going to create arc lines for making a patch surface. So I have enough 3D lines to create patch surface. So I click on patch surface and I click on the line that I want to use for creating the surface. Click on the boundary. Okay, this is the first boundary line. Okay, next second boundary line. Okay, done. So okay, here is the surface of the 3 models created in the CAD or the Autodesk Inventor. Next, I'm going to stitch it together. Click on stitch. Done. So now we have a single face here. Okay, next I'm going to unwrap it. Click on the surface that I want to unwrap. Okay, this is a flat pattern. It's also display the stress on the fabric, where in the place that it's going to stretch is to turn to a red color. But this one doesn't stretch that much, so it's only some point here. So this will be a cutting pattern. So to export the cutting pattern, you can create a sketch and project geometry on the edge. Click on OK, finish the sketch. So this will be a cutting pattern. Right, then you can click on export sketch as. You can export in a DWG or DXF. Okay, this is an AutoCAD. So you have a 2D line for cutting. You probably need to offset for the stitching lines. So now you can offset for the stitching line. For this example, I use 20 is too much, I guess, like 15 millimeters offset for stitching lines. All right. So here's how you use a 3D scanner to scan the car seat and making the cutting pattern. All right. Thanks you guys for watching. I'll see you in the next video.